T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavour, go at throttle.
Die Weltraumbehörde NASA hat eine unbemannte Forschungsstation ins All geschossen. Swift, so der Name, wurde von Cape Canaveral aus gestartet. Das mit 3 Teleskopen ausgestattete Himmelsobservatorium soll in den kommenden 3 Jahrzehnten die Herkunft der als Gamma-Blitze bezeichneten Energieausbrüche erforschen. Die NASA erhofft sich außerdem weitere Erkenntnisse über den Ursprung unseres Universums.
Ein unbemanntes Testflugzeug der NASA erreichte jetzt einen neuen Weltrekord. 10-fache Schallgeschwindigkeit. Der Megaflitzer arbeitet mit einem revolutionären Triebwerk. Ausklinken zu einem Höllenritt. Auf knapp 10-fache Schallgeschwindigkeit beschleunigt das unbemannte Flugzeug in 20 Sekunden. Mach 9,6, 10.630 Stundenkilometer erreicht das Hyperschallflugzeug über dem Meer vor Kalifornien. Ein neuer Geschwindigkeitsrekord. Anders als Raketen verbraucht der Sphärensprinter Sauerstoff aus der Atmosphäre. Als Treibstoff wird Wasserstoff verwendet. Das neuartige Scramjet-Triebwerk jagte in 30 Kilometer Höhe um den Erdball. Mit 10-facher Schallgeschwindigkeit wäre ein Hyperschalljet von New York aus in einer halben Stunde in Berlin. Es wird eine ganze Weile dauern, wie vom Flug der Gebrüder Wright zum ersten Passagierflug über den Atlantik. Aber ich denke, eines Tages wird man den Scramjet-Antrieb kommerziell nutzen. Die erste zivile Überschallmaschine, Concorde, brauchte für einen Transatlantikflug 4 Stunden. Sie ist mittlerweile im Museum gelandet. Jetzt geplante Überschallflugzeuge sollen 2000 Stundenkilometer erreichen, nicht mehr. Anders das US-Modell. Die NASA will mit dem Superantrieb Fracht günstiger ins All transportieren. Das 230 Millionen $ Projekt dürfte auch das Militär interessieren, denn Washington plant einen strategischen Bomber, der in 2 Stunden jeden Ort der Welt erreichen kann. Der Wunderflug von X-43A endete übrigens unrühmlich. Es versank wie geplant im Pazifik.
And yes, SSVP mode has been executed. We have the separation is okay, and we're observing this.
This is Mission Control Houston. You can see the physical separation of the Soyuz spacecraft from the International Space Station, with Soyuz Commander Salazar Sharipov at the controls inside the descent module, along with astronaut Leroy Chow.
Downwards and towards the starboard. You have a go to activator become. Yes, activating roll call. The range is 8 meters. Copy.
Отвечаем ССВП, отвечаем. Питон Т-7, еще раз, ССВП.
Once again, SSVP.
Так, я... Сказал, да?
Done? Yeah, I could see it. It is the way it should be. Okay.
Ага.
The range is almost 30 minutes and ready for station keeping. Copy. At 12:45, please activate G3 transmitter for COM recover. Copy. That'll be done. We are aware of that.
This is Mission Control Houston. The Soyuz spacecraft now in position in front of the Zarya docking port. Sharipov now rotating the Soyuz 135 degrees to align it with this new docking port.
20 meters. There was a com break. Copy. You have a go to come closer, but wait for our go, for MCC go for docking. Copy.
This is Mission Control Houston, the Soyuz spacecraft inside 20 meters from the International Space Station, with Sharipov standing by for the final go from the Mission Control outside of Moscow for the final approach for docking.
Please give us the range. 25 meters. Copy. And we're still moving, approaching. Yes, we're aware of the approaching movement. Copy, concur. Display TV, activate it, enable it. Copy, display TV. The target is in the center and full alignment. The range is 20 meters. Copy. The range is 3 meters. Copy. And the hooks are have been aligned. Moscow is inaudible. The range is 2 meters. Waiting for the touch. SSVP has been done. The DPO firing. We have the touch and we have the docking mechanisms engaged. SSVP has been done.
Ist am Abend eine Ariane-Rakete von Kourou in Französisch-Guyana ohne Zwischenfälle in den Weltraum gestartet. Sie hat 7 Satelliten an Bord, unter anderem den Spionagesatelliten Helios 2A. Bereits eine Stunde nach dem Start wurde der Satellit erfolgreich in 700 Kilometern Höhe über Australien ausgesetzt. Helios 2A soll für Frankreich, Spanien und Belgien militärische Aufklärung betreiben und ab März dann auch nachts Bilder aus jeder Gegend der Welt liefern.
I'm out. Okay. Ready? I'll you out. Good. Easy. 3, 2, 1, snap.
Good afternoon. Welcome to NASA headquarters and today's briefing for the Deep Impact mission. The launch of Deep Impact is coming up early next month, and here to tell us about that mission and the science of the mission and about the comet that it will be going to, we have a panel from the Deep Impact team, and I'll introduce the speakers today. We'll start off with Andy Dantzler, who's the director of the Solar System Division here at NASA headquarters. Next, we'll be hearing from Dr. Tom Morgan, the Deep Impact Program Scientist at NASA headquarters. Next, we'll get a good description of the mission and the spacecraft from Rick Ramir, the Deep Impact Project Manager from NASA's Jet Propulsion Laboratory in Pasadena, California. And our science team members to speak to us about the science of the mission, we'll start with Dr. Micah Hearn, the Deep Impact Principal Investigator from the University of Maryland in College Park, Maryland. And then we will hear from Dr. Karen Meach, the Deep Impact Co-Investigator from the Institute for Astronomy in Honolulu, Hawaii. And we'll start with Andy Dantzler.
Thanks, Todd. Welcome, everyone. In NASA's long tradition of innovative robotic exploration of our solar system, which dates back to 1962, it seeks to answer the fundamental questions of how did our solar system form? Why is it the way it is now? And how will it evolve? Does life exist beyond Earth, and can it be sustained beyond Earth? And also, when we look at other stars to search for other planetary systems, what sorts of things should we look for? Comets, which are the oldest bodies in our solar system, hold the clues to the answers to many of these questions. And the quest to understand comets will continue in January when we launch Deep Impact on its journey to Comet Tempel 1. A Deep Impact's rendezvous in space with Tempel 1 will be the first time that a spacecraft has ever touched the surface of a comet. In fact, the impactor will penetrate the comet's surface, blowing material away from the surface of the comet and revealing the mysteries of the interior of the nucleus. Deep Impact is a project in the Discovery program of competitively selected missions. The Discovery program is it seeks to enable solar system exploration through moderately low investment, relatively frequently launched innovative missions, which are led by a science leader called the Principal Investigator. The Deep Impact, like all Discovery missions, is a collaborative effort amongst government, academia, and private industry. But in the case of Deep Impact, this collaboration goes well beyond the norm, in that this mission entails, a vast array of ground-based telescopes and space-based telescopes, all pointed at the right place at the right time, all coordinated in order to capture this event, the impact on Comet Tempel 1. All looking through various vantage points and through different analytical instrumentation. Excuse me. The accomplishment of this collaboration is a tribute to the science leadership of Deep Impact's Principal Investigator, Dr. Micah Hearn. And Deep Impact is also unusual in that the spaceflight portion of this mission is only 6 months long. The data analysis will continue several months after the impact itself. But given the relatively short time in space, there's not going to be very much margin for correcting in-flight anomalies or in-flight problems. So I can assure you that the technical project team, as led by Rick Ramir, the project manager, has exhaustively checked and rechecked every detail, every test, every result, and every piece of documentation in order to ensure that this mission will be as successful as humanly possible. We're all looking forward to an exciting several months coming up, starting with the launch, as we send Deep Impact on its way and continue to unfold the story of our solar system. Tom?
Thank you. If I have the first graphic, we have an image of a comet which is familiar to most of you. It is a beautiful object in the night sky, typically with a bright head called the coma, and one or more tendrils running out from the coma, extending away from it, which are typically called tails. What we're interested here today is the source of the dust and gas that forms the coma, which is a small core of ices, organic compounds, and dust called the nucleus, which is typically a few miles in diameter. These objects are of interest to us because they are literally the leftover building blocks of our solar system. What does a nucleus look like? We have in a video here, which we got from the stardust flyby of the nucleus of Comet Filth 2 early this year, which I hope we will be running now. And as you see, as we show the passage, stardust passed within a few hundred kilometers of the nucleus. This is about a few miles in diameter. It's approximately the size of the a nucleus of Temple 1. And you'll notice these are fascinating objects. There are all sorts of structures there. There are craters, tower-like structures, cliffs. And we've learned a great deal from studying the imagery of the surface. But what we haven't learned to date is, what we don't have is direct knowledge of the interior of a comet nucleus. And this is what brings us to Deep Impact. For it is Deep Impact which will be the first mission to peel away the outer layer of a comet nucleus and allow us to look into the interior of a comet nucleus. Rick?
Thanks, Tom. I'd like to start out first by acknowledging the wonderful team of scientists, engineers, and technicians that have made this all possible. Obviously, the scientist team led by Principal Investigator Mike Ahern. We have a lot of engineers and scientists as well at Jet Propulsion Lab that have contributed to making this mission possible. And of course, our industry partners from Ball Aerospace Technologies out of Boulder, Colorado, who basically did a lot of the design for the flight system and put it together and tested it along with the JPL team. It's just been tremendous working with this talented group, and we are looking forward to a very successful mission. What I'd like to do is take you a little bit, show you a little bit about the flight system, talk to you about the mission. The first graphic that will come up is a picture of the cratering mass that you see in front of Dr. Ahern here. This is about 317 pounds of copper. It's the primary impact mass that will create the crater in the nucleus of the comet. And it is actually carried by what we call the impactor spacecraft. Deep Impact actually consists of two spacecraft, one an impactor that hits the comet, and then another spacecraft that we call the flyby, which is basically the mothership for the impactor until about 24 hours out. Let's see, on the next graphic, you'll see a good picture of the entire impactor spacecraft itself. This spacecraft not only carries the copper cratering mass, but it also has the impactor targeting system, which is an optical system. It has its own set of electronics. It has its own propulsion system, and it uses optical navigation software to make its way to the comet on its own once it's released. The next graphic that I'm going to show you will show you the flyby spacecraft, which is at the top there, being lowered onto the impactor spacecraft. As you can see, it's quite large. It's about 5.5 feet wide by about 7.5 feet tall. When you put the solar arrays extended on it, that's about 11 feet. What's facing you in the foreground is our instrument platform there that consists of the two main instruments, the high-resolution imager on the bottom and the medium-resolution imager on the top of that.
And then on top of that, at the very top of the spacecraft, you'll see the high gain antenna, which is our primary communications back to Earth during the encounter phase. And finally, in the background, you'll see that the solar array panel is there, which provides us about 740 watts at the time of encounter. So that in a nutshell, and then you'll see that the impactor itself is underneath and is carried by the flyby until, as I said before, we get close to the comet. This next video clip that's coming up will show you that the spacecraft is, how it looks cradled inside of the launch vehicle getting ready for launch. You can see that the high gain antenna, of course, is pointed toward the top, and the impactor itself is down at the bottom toward the launch vehicle. And you see the star camera there, basically that's a part of the impactor spacecraft. So that's what it looks like when it's cocooned inside the fairing. And then what we're going to show you next is basically a video clip on the launch itself. This is on a Delta 7925. It has 9 solids. You'll see that the solids come off in stages, the first 6 and then the final 3. And this gets us started on our journey. We come off the main launch vehicle and then get put into our interplanetary trajectory. You'll see us get spun up and released. Now the first thing we want to do, of course, as we come off the launch vehicle is detumble and get our solar arrays deployed and pointed on the sun so we become power positive. At about the same time that we're doing that, we actually turn on the communication system so it'll start warming up, and then probably 15 minutes after we separate from the 3rd stage, we rise over the Deep Space Network at Canberra, Australia, to get our first transmissions back and start checking out the health and safety of the spacecraft. The next video that you'll see is actually a video of the trajectory itself. As was mentioned before, it's only a 6-month journey. You'll see the comet approaching on the right-hand side of the screen there. Actually, we put the impactor in front of the comet, and it's overtaken by the comet. It has a relative impact velocity of about 23,000 miles per hour. And then the flyby spacecraft, after releasing the impactor, basically corrects its trajectory so that it gets a good view of the comet nucleus at the time that the impactor hits. And it takes the scientific data associated with the impact, the crater formation, the ejecta, and then eventually the actual formed crater itself, and then flies underneath the nucleus while it's taking these pictures, and then turns back and takes a final look-back set of images of the nucleus itself and observes that crater. So now to talk to you more about the science of this is Dr. Ahern.
Thanks, Rick. I want to start out by talking about why a technologically challenging but conceptually utterly simple experiment is worth doing in the first place. As you heard from Andy and Tom, the comets formed in the outer part of the solar system and preserve clues to the formation. The first graphic shows where the comets are today. They formed from Jupiter on out to beyond Neptune 4.5 billion years ago, together with all the planets, and the inner ones got ejected to the Oort cloud, which now extends halfway to the next star, whereas the ones that are formed in the Kuiper belt are probably still in the Kuiper belt in large part. We are examining comets that come in from the Kuiper belt with deep impact. The problem in understanding the comets is that each time the comet goes close to the sun, the surface layer gets heated, and this changes the surface layers. So it's only the interior that preserves the clues to the formation of the solar system. The next graphic shows a couple of different models for how much the surface has changed. And we have very few data that are relevant to constraining these theoretical models. So the theoreticians make different assumptions about the physical properties of the comet and get very different models. The most extreme models on one end would have the evolution proceeding to a depth of 10, 20, 30 centimeters, a foot or so. whereas the most extreme models at the other end would have the evolution proceeding more than 100 meters deep. And the problem is that there are no data on the interior, and that's what we hope to solve with deep impact. A related question is that the comets we know eventually stop outgassing. Why is this? Is this because they've exhausted all of the gas that's in the interior? All of the ices have evaporated, the gas has flown out? Or is it because at the surface layer we've developed some sort of a crust of organic goo or just a weight of overbearing materials that prevents the ice inside from evaporating and escaping as gas? And finally, we want to understand the structure of the outer layer, something that we have essentially no information on. So we're going to do this by going to Comet Tempel 1. Why Comet Tempel 1? It's a typical comet that ultimately came from the Kuiper Belt, and it was chosen because it has a large nucleus. We can get there at the right time. When we get there, we can easily see the event from the Earth. That was an important consideration. And the cloud of dust and gas around the comet nucleus is relatively weak, so that the problem of targeting the spacecraft is simplified and surviving passage through the dust is simplified. Now, the animation shows what will happen as we come up. The impactor is released from the flyby spacecraft directly in front of the comet, and the comet is going to actually overtake the impactor and run into it as they go around, both go around the sun. And you see here a big cone of ejecta coming out of the crater. This animation is based on the science team's assumption that the crater on the nucleus will form but will be controlled by the gravity of the cometary nucleus. And we think that will be the case. We've been doing experiments in the laboratory shown in the next animation, which is actually a film of experiments done at NASA Ames with a vertical gun that shoots pellets into various targets. And again, you see this cone of ejecta coming out. Now, there are other theoreticians who've argued that the comet is very strong. And if the comet is very strong, this ejecta cone that you see here staying attached at its base to the surface of the comet, or the surface of the tub of pumice in this particular case, that cone, if the nucleus is strong, will simply detach and lift up away from the surface. So just by looking at the shape of the cone, we can learn something about the strength of the cometary nucleus, something that we know nothing about on scales of meters to hundreds of meters at the present. Now, the biggest uncertainty in the mission is what the phenomena will be at the time of impact. And that is because there are many different ideas in the scientific community about the nature of the cometary nucleus. There are some people in the community who think that the nuclei are strong and that we will have an ejecta cone that leaves the nucleus entirely. We think the cone will stay attached to the nucleus. The crater will be controlled by gravity. Other people think that we will fracture the nucleus into several pieces. Other people think that we may just compress material downward and not eject anything outward, or almost nothing outward. It is this uncertainty in the predictions, or the wide range of predictions, that makes it particularly important to do this conceptually very simple experiment. Now, how will we study what happens? On the spacecraft, we have two instruments on the flyby, and we have one instrument on the impactor. The impactor will give us the highest resolution pictures of the nucleus ever. This graphic shows us the instruments on the flyby spacecraft. The high-resolution telescope will be the largest telescope to go to deep space. It's small compared to HST and Spitzer, but it's large compared to the cameras we normally fly on interplanetary missions. This telescope has both a camera for imaging and an infrared spectrometer for studying the composition of the gas and the dust. The small square aperture on that graphic was the wide-angle camera that gives us the context of the entire nucleus at the time that the high-resolution camera is aiming only for the crater itself. Now, these two instruments will take most of our data from the flight mission on the 4th of July of this coming year. But there are so many possible outcomes of the experiment that we need also many other kinds of observations, and we can't fly an entire observatory of 20 different kinds of instruments on this mission. So much of our effort has also been focused on observing the comet from other facilities on the Earth, and Karen Meach is in charge of coordinating those observations, and she'll tell you about them.
Thank you. Well, this is a very unique mission in that much of the scientific return is going to come from an Earth-based observation campaign, both from Earth orbit and from the ground. And this will give us coverage of different wavelengths that we won't be able to get from the spacecraft, as well as different time scales that we won't be able to follow from the spacecraft. So the two phases of this have been the pre-encounter phase to characterize the nucleus, and then the coordination at the time of encounter, including the days afterwards. So from the pre-encounter point of view, we've spent roughly 5 or 6 years working on observing the comet using over 300 nights of large telescope time involving 10 countries and dozens of observers to attempt to characterize what the comet is like. This is partly for the benefit of the mission so that we can better plan for the mission, but also from the point of view of establishing a baseline of what the comet is like now so that we can assess changes after we hit the nucleus. So the types of data that we're going after with this pre-impact characterization include measurements of how big the comet is, how dark it is. This enables us to calculate proper exposure times for the spacecraft, as well as being a fundamental scientific property of the nucleus. In addition, we've spent a lot of time trying to characterize how fast the comet rotates in space, and I've got a small nucleus model here. Everything tumbles in space, and this particular comet we've discovered rotates once every 41 or so hours, and it will be important when we get to the comet to be able to arrive on one of the large sides to give us a larger targeting area. So we spent a lot of time trying to characterize how fast it spins. In addition to the rotation rate, especially this coming spring, we're going to be characterizing how much dust is coming off of the comet. A comet is basically, as you've heard, a giant dirty snowball, which as it approaches the sun, the gases will start to vaporize from the surface, given energy from the sunlight, and this will push dust away from the comet. What we would like to do is characterize how much dust there is, how big it is, how fast it's moving, and this will give an idea of the environment through which the spacecraft is passing. So this first graphic will show you what the dust looks like around the comet. In the image on the left, this was taken when the comet was moving away from the sun in August of 2000. The scale on there is shown by the scale bar at the bottom, roughly 50,000 kilometers or 30,000 miles. You can see there's a long tail stretching off to the right. Now the image on the right, both of these are negative images, so dark things are bright. The image on the right shows the comet at the same distance from the sun as a small dot in the middle, but this time it's moving inwards. So the comet is still cold and it hasn't formed a large dust tail yet. There's a little bit of dust if you can see it, but it's less than 20,000 kilometers in extent. Starting now, the comet is visible again, and it will brighten fairly rapidly throughout the spring and start to develop a large dust cloud. And in fact, we'll have a very vigorous program of amateur observers watching it as it gets bright enough for small telescopes. Well, this is a program that involves not only ground-based facilities, but we're going to have a very rich program using Earth orbital satellites. So our next graphic shows some of the facilities that we'll make use of. The great observatories in orbit around Earth. The Hubble Space Telescope we'll utilize in the ultraviolet region to look at some of the molecules coming off of the comet. We'll use the Spitzer Infrared Telescope to look at organic volatile molecules as well as dust. The Chandra X-ray satellite, as well as a host of other smaller satellites. Of course, we can't forget about the ground-based facilities. This will be a major part of our coordination effort. The next graphic shows a number of the facilities that we've already coordinated. These are highlighted by red dots. Basically, people at the time of encounter will be able to see the moment of impact ranging as far east as observatories in Arizona and as far west as New Zealand. Outside of those regions, it doesn't mean they won't get to participate in the event, because we think it may take hours to days for some of the activity to develop. So all of these highlighted areas will play an important role in the observing program for deep impact. Of course, one of the most important ones in our last graphic is the summit of Mauna Kea, where this is the largest international collection of observatories that will be in the path of the encounter itself, watching the actual moment of impact. There's 12 observatories up here. All of them will be pointed at the comet. The observing time will be awarded through a competitive process, and everybody on the mountain will be looking at the time of encounter. So that summarizes our deep impact story. I'll go back to Don.
Thanks. Before we go to Q&A, I think we'll go back to Rick Lemire just for a brief update on the launch.
Oh yeah, I forgot to mention that the launch right now is scheduled for no earlier than January 12th, this coming January, and also our impact is scheduled for July 4th this summer. A little bit early in the morning Eastern time, so we expect to provide some great fireworks for all our observatories, and that's exciting to do it on July 4th.
All right, thank you, panelists. We'll start here at NASA headquarters with any questions. Please wait for the mic and give us your name and affiliation. Robert?
Robert Boyd from Knight Ridder. I want to make sure I'm correct on one thing. And next January, when Huygens hits Titan, that'll be the furthest spatial object to be actually touched with something from Earth. And that record will be then broken next July 4th, if all goes well, by Earthing. Are those the two furthest objects we had, or will have had?
I believe that the Huygens will take that prize. We're about 83 million miles for the impact with deep impact from Earth. We travel a total of about 268 million, but by far I think Cassini and Huygens. I'm sorry?
Inside Jupiter at impact? Within, closer than Jupiter?
Yes. Yes. Yes.
Question here. Or Warren, back row.
Thank you. Warren Leary, New York Times. Some questions about the impactor. You have a camera on it, which I assume would be instantly destroyed. Are there any other instruments or anything else on that craft that will give you information as it goes in, as it is crushed, as it were?
There are no other scientific instruments on the impactor. The camera is the only one. That will give us the highest resolution pictures of the unperturbed surface that will ever have been taken. The camera itself will probably be sandblasted in the last half minute before impact, and then, as you said, the entire camera and impactor will be destroyed at the moment of impact. There are lots of other things on there in order to make the impactor be a fully functional spacecraft: propulsion, attitude control, computers, auto navigation so that it can get to the target, radio link from the impactor to the flyby spacecraft in order to transmit the images back to Earth.
Camera and that impactor, how high will it be, do you think, when you get your last picture, before it's destroyed or sandblasted? And then what kind of detail in terms of how small an object could you see without blurring when you come in?
This all depends on the rather uncertain environment of dust near the nucleus. If the dust is very low, the last image will be taken a couple of seconds before impact. That would be something like 20 kilometers above the surface, and we'll have a scale of 20 centimeters per pixel, something like a 1 foot resolution. If it gets sandblasted in the last half minute, say, that would put it at 300 kilometers above the surface. So that would be a factor of 10 worse. So you would have a resolution of about 10 feet or 3 meters, something like that.
Down the front row.
Yeah, Jeff Morris with Aerospace Daily. This may be a dumb question, but I was wondering, I mean, is there any possibility of this impact in any way changing the trajectory of the comet, or is it a total, just a head-on hit?
The impact, of course, will make a change in the orbit of the comet, but the change will be so small as to be undetectable. To put it in perspective, the entire nucleus would easily fit inside the city of Washington. The distance of the comet from the Earth at its closest possible approach ever, the closest approach to the Earth's orbit, is half an astronomical unit, call it 50 million miles. We expect that we cannot change the orbit of the comet any more than moving the city of Washington's center from the Capitol to the end of the mall.
Any more questions here at the headquarters? Guy?
Guy Guglielmo of the Washington Post. Originally, the deep impact was scheduled for launch, I believe it was the 30th or the 31st of December. Why have you moved it back, and did the physics not line up if you wait much longer? In other words, is there a window, or can you do this whenever you want?
Well, I'll answer the second question first. Our launch window extends to about the 28th of January, and that's a pretty hard launch window. If we don't make it then, we'd pretty much have to stand down or select another target of opportunity. It was originally scheduled to go off on the 30th, and what we discovered when we were doing one of our extra checks, we have a series of checks that we do. We were looking through what we call our parameter reviews, which is where we sit down with the engineers and go all over all the software parameters that we have to make sure they're all set appropriately. And during that review, which is why we do the review, we discovered that there were a couple of parameters that were not set the way we expected them to be. So as an extra precaution, I asked for a delay in the launch in order to give us time to go back and rerun some tests that we had already completed. And we wanted to go back just to make sure that the interaction of turning those parameters on did not affect our fault responses that we had already tested and validated. And so we needed the extra time to not only run a couple of additional tests, but to also review the data from those tests. So that was basically the reason for the original delay. And then recently we had another delay due to some launch vehicle issues with the inner ring. Again, in one of the extra checks that was being done, which is called a review of the engineering paperwork, the Boeing folks discovered that the inner ring, inner stage ring they call it, had not had an appropriate heat treatment on a portion of it, and thus they called an engineering review board and determined that the best thing to do would be to change that piece of the launch vehicle out and replace it with one that had in fact passed and done a full check and passed all of its paperwork. So those things together kind of lined up to delay the launch. Having said that, I'm very positive on it because it shows that our checks that we've implemented and put in place are actually, that's why they're there. They're there to take one last look at things, make sure things are in tip-top shape, and they did catch a couple of errors, and that makes me feel confident that our system's working.
Okay, well, one more follow-up, and then we'll go to our center. Warren?
Warren Leary, New York Times, again, following up on the last question. You mentioned this launch window will be over on January 28th. If for some reason you don't make it, what's in the wings in terms of another launch time and another target?
Well, I guess there's two ways to answer that, and I'll let Mike answer the second part of it. But first off, I have every confidence that we're going to make it by the 28th. I mean, we're well positioned now. We're finishing up our final checks on the flight system, getting ready to move it over and get it fueled. and we've basically completed all of our testing, and we're just finishing out the open paperwork and closure. So I honestly can't see that we wouldn't be ready to launch during the launch window that we still have remaining. There's still quite a bit of time, actually. That's about 2 weeks. I talked to the launch vehicle folks today. They're confident that they will be ready to go. They've already selected the replacement piece. They're getting ready to stack that on the current existing first stage. And so I think we're good to go. Now, as for the second part, I'll let Mike answer that about any other targets.
Yeah, the present starting launch date of January 12th is actually very close to the middle of our window, so it takes the minimum launch energy. The window is symmetric about the best opportunity. So we're in good shape in that regard. If we fail to make it off by the 28th, then we have to look at other possible targets. We've done some preliminary work. There are other targets we can go to. We've looked at half a dozen different comets. Each of them is not as good as Temple 1 in one way or another, which is why we do not want to delay the launch. We could, for example, launch several months later and go to Comet Schwarzmann-Bachmann 3, which is the comet one of the comets that the Contour mission was scheduled to fly to. This is less desirable because it's a small nucleus, therefore a little harder to target, and it has more dust around it, so that makes the targeting harder as well. In other respects, it's a fairly good encounter. But the small target and the large amount of dust is particularly challenging.
Okay, we'll come back to headquarters. So we've got to pick up some questions now at Kennedy Space Center, and then we'll move on to the AGU in San Francisco. Let's go to Kennedy Space Center. Please give us your name and affiliation and ask your question.
Hi, it's Chris Kreidler from Florida today. First question is for Karen Meach. How much can the ground-based telescopes see? What can we expect to see out of them?
Well, at the time of encounter, we may be able to see a bright flash of light momentarily, but main part that we're going to be looking for from the ground will be some of the long-term effects and to get different wavelengths and different timescales. For example, as the dust that we create newly from this excavated crater starts to flow away from the comet, it will take many days to spread away from the comet and form a nice dust tail. And to the extent that we want to see how big that dust is, how much there is, we need to have that time for the coma to develop. And so ground-based observations with wide angle field of view can best watch the tail develop. In addition, we will get to look at wavelength regions that we won't have on the spacecraft and can look for molecules coming outside of the nucleus, different wavelengths, different types of molecules in the comet. We're hoping to see a change in the chemistry after the impact as compared to pre-impact. So there will be a lot of exciting science at various wavelengths, various observatories all over the world. So basically everybody's going to be able to participate.
Thanks, and one more question from me, which is, what happens to the flyer part of the spacecraft after the encounter and after it's made its observations of Temple? Is it going to do anything else?
Right now, what's going to happen after encounter is it's going to basically retransmit its data. We transmit the data in real time because we are taking the flyby within about 500 kilometers of the nucleus, and there's always the possibility of damage from the dust. But basically what we do starting a day after the encounter is spend the next 30 days retransmitting all the data that's recorded on board at the same time. And after that, we call that the end of mission as far as the flyby spacecraft goes. It'll be in an orbit that comes nowhere close to Earth at all. There is some talk about some possible follow-on missions, but of course that has to be competed as part of the Discovery program. Perhaps visit another comet. I think Dr. Ahern's had a few ideas along those lines. Do you want to say anything more about that?
Yeah, we have identified at least 2 other comets that we could go to in an extended mission and do a flyby with what would be still the most powerful camera and spectrometer in in a position to make any measurements and get very good close-up measurements of one of those other two comets. We have not yet chosen which one we might propose, but as Rick said, we have to go through the proposal process in order for this to happen.
I actually did want to add one thing to what you can see from the ground. And I don't know if people have noticed that the comet may actually get quite bright. And normally this comet is not naked eye visibility, but there is a possibility it will reach naked eye brightness. And so amateur observers and the public may get a chance to see something happen, either real time depending on where they're located, or they may look for a comet that they couldn't see the night before in the night sky. And it will be nicely placed for observers somewhat near the bright stars Spica and Jupiter. So people who aren't used to looking at the sky may be able to see it quite nicely.
More questions from
Associated Press. Question for Dr. Ahern. I'd like to know a little bit more about the ground crater tests that were conducted. How many of them were there? Did you use moving targets? How tricky was it? And the big question is, did you miss in the test, and would you think you might just miss the comet entirely when the impactor is released? Could you discuss all those points, please?
Sure. The experiments that we did were aimed at understanding the cratering process. We actually did no targeting tests in those experiments. Out at NASA Ames, there is a vertical gun that shoots pellets into targets, but the gun is positioned maybe 20 or 30 feet up above the target and just shoots straight at it. So there is no issue of targeting. We've done, probably 100 or 200 shots with the gun with various kinds of targets and various kinds of impactors to understand the scaling relationships between the final crater and the pellet that we put in, and its speed, its mass, its density, things like that. There are many people doing this. The 100 or so experiments have been done just by one of our co-investigators on the science team, Pete Schultz. But there are half a dozen other groups around the country who do these kinds of experiments as well, and we've tried to synthesize all of those experiments to understand how the crater tells us about the nature of the comet.
And my other question along those lines was, would you anticipate missing the comet on July 4th? I mean, is that even a remote possibility?
I'll let Rick answer that one.
Right now, based on our testing that we've done, I guess let me back up and say that the optical auto navigation software that we're using actually has a very good history to it. It started out with Deep Space One, and then has been refined a little bit more on Stardust. You saw some of the film when we were talking earlier about the Stardust encounter. We've basically taken that the next generation, and we test that through a series of simulations that bring into not only the comet models that Dr. Ahern and his team provide us, all sorts of comet models, worst case, best case, medium case. We build around that simulations of other things such as cosmic rays, what have you, and the actual flight system itself. We then, in a closed loop environment, run those tests stimulating the instrumentation and the AutoNav software, and then start exploring the boundaries of that as far as the robustness, what are the parameters that it's more sensitive to, and being able to accurately pick out the target. We not only want to target the nucleus, but we also want to hit it on the lit side so that you get much more science from it, so the side that's lit by the sun. And we've put that into the algorithm itself so that it can calculate dark spots and tell dark spots away from bright spots. We're still doing that today. We've been keeping a pretty good record of how well we're doing, and we're actually doing quite well. And right now, and all the way up to the actual encounter itself, we're going to continue this type of testing and robustness testing and independent review. Now, our current calculations right now say that it's less than 1% chance of us missing the target. We all feel pretty comfortable with that. But as we've all said before, we're doing something we haven't done before, and so we're going to keep testing and seeing what this is most sensitive to in the way of the environment that the comet could present to us, as well as spacecraft behavior, and keep testing away at it. Test, test, test.
Okay, we're now going to go out to the West Coast to San Francisco and take questions from reporters attending the meeting of the American Geophysical Union in the Moscone Center. Please give us your name and affiliation and direct your question, please. Go ahead.
This is Alexandra Whitty from the Dallas Morning News. I have a scheduling question. If the launch date is pushed off, how does that affect the arrival date? You know, if you launch on the 9th of January, does that mean you get there on the 5th of July? And also, what is the cost, including launch of the mission?
Our impact date does not change with the launch window that we've given you. In other words, no matter when we launch in that launch window through the 28th of January, we still perform the encounter on the 4th of July.
And the cost?
The total cost is approximately $280 million.
This is Robert Urian from Science Online. I have a question for Dr. Meach. You mentioned the impact might be visible to the public. I'm curious about whether your science team has any concerns about public reaction of scarring or damaging or otherwise interfering with a celestial object for really the first time.
Well, of course, we've addressed these issues, but we're actually reproducing a natural process that occurs all the time, and we've seen that with other missions. We've seen comets and bodies in the solar system which have impact craters. In a sense, this is a very small mark we're going to put on the comet. It's a fairly small crater in comparison to the size of the nucleus. And again, it is reproducing a natural phenomenon that we see all the time.
I might add that we in the past, experiments have also done similar things, particularly during the Apollo program, when we dropped lunar modules and spent Saturn boosters on the moon in order to study the seismic properties of the moon that were then measured with the seismometers that the astronauts had left behind. So this is a well-established approach to doing science.
Next question. Let me make a quick adjustment.
And one follow-up for Dr. Meach. Do you have plans for outreach to school programs to get students involved with possibly watching this event?
Yes, we have a very vigorous outreach program, and that's led by Lucy McFadden at the University of Maryland, which involves school programs, public programs. We've got teacher programs trying to train them how to observe the comet with their students in the hope that we can establish some science fair projects this spring and during the follow-up. So we have a very well-developed outreach program, which you can access information on our website.
I'd like to go back to the question about costs. Just to be completely clear, if I include the cost of the spacecraft, the launch vehicle, mission operations, and everything else, it all comes to about $330 million.
Go ahead and restate your question, please.
I'm Barbara Moran from WGBH-TV Nova, and I was wondering if someone could talk a little more about the design of the copper impact device a little bit. Why is it that discus shape, and why is it made out of copper?
Well, first let me address the reason it's copper. Facetiously, it's because it's from the same part of the periodic table as gold and silver, and it's cheaper. But all those metals, copper, gold, silver, don't react with water very efficiently. They're the noble metals, and we want our impactor not to react with the cometary materials. If we made the impactor entirely out of aluminum, the aluminum would react very rapidly with the water, and we would get bright emissions from aluminum oxide that make it very difficult to see the things that we're interested in the spectra. So the copper was a choice to minimize the interference with the observations we want to make. The shape is basically a spherical cap, and that is to minimize the sensitivity to the local topography where we hit. So if we hit on a side of a steep hill, for example, the effect is no different than if we were to hit on a perfectly horizontal surface.
Okay, we're going to bring the Q&A back here to NASA headquarters for any follow-ups. Anyone else? Warren, can you get the microphone over?
Question about if we were successful with this mission, you'll have essentially a sample of one of creating a comet. How confident are you this is really representative of what comets really are? And don't you need to, how typical is Temple 1 as we can define typical now of a comet?
As far as comets from the Kuiper Belt are concerned, Temple 1 is very typical in every measured property. Now, that's only a small number of measured properties, but we have no reason to think that it's unusual. There's probably a spread of properties over some range, but Temple 1 should be well within the range that we would call normal. There may be systematic differences between the Kuiper Belt comets and the Oort cloud comets, and in fact, one clearly should do a similar experiment on an Oort cloud comet to find out what the differences are.
Course correction is autonomous or direction wrong? Yeah, when you're on the way to the comet.
Those will be autonomous. After we do some trajectory correction maneuvers and actually get to the release attitude about 24 hours out from encounter, then they basically start the auto navigation. They start taking pictures more and more frequently, and then they start the actual auto navigation about inside of 12 hours of the impact, and that's automatic.
Ride that if you needed to?
I'm sorry?
Do you have the power to override that if you needed to?
If we needed to, yes, but we're testing that so we don't have to. The reaction time from the ground, we could still do that up until probably inside of 2 hours, but once you're inside that 2-hour window, you pretty much got to be all on automatic to make it work.
Any?
Guy Gugliotta from the Washington Post. One more question about the projectile. I think you said at the beginning that it weighed 319 pounds. Does it weigh that much because that's the biggest projectile you can carry up there, or would it be bigger if it could be, or is it an optimum size for some reason?
There's lots of ways to answer that.
Okay, the 319 pounds was the reference to the copper part. The entire impactor is, with the fuel, is 370 kilograms, so something like 800 pounds. So the impactor is bigger than that, and basically we want the impactor to be as large as we can carry on a rocket that we can afford, and that's what sets the limit. It turns out that for design considerations, we didn't go another 10 or 20 kilograms heavier that we still could have done. But ideally, if we could do 1,000 kilograms, that would be nice. But we don't have a rocket that would do that.
I think it's important to note and point out again that basically these are two fully functional spacecraft that we're putting up there. It's not just one, it's two spacecraft in one. And that obviously limits you somewhat in the amount each can weigh. But I think Dr. Ahern has it right. We put as much of that copper mass in there as we could to still be able to form the crater that's desired.
Any last question from headquarters? Okay, thank you very much for being with us today. Thank you, panelists. We're looking forward to, once again, to launch January 12th, 2005. The next thing we'll have on NASA TV following this program is a post-show feed of the graphics from today's press conference. And we will also pop up on the screen momentarily the website where you can get more information, video, other graphics about the mission and NASA. And the next Deep Impact press event will be the day before launch from the Kennedy Space Center in Florida. And we'll see you there. Thank you very much.
Ein Gletscher explodiert. Vulkanausbruch auf Island. 13 Kilometer steigen die Rauchwolken hoch bei diesem Schauspiel aus Feuer und Eis. Ausbruch des Volkswillens in der Ukraine. Aus dem Protest gegen die gefälschten Wahlen wird ein Volksfest. Eine samtene Revolution, ganz Kiew in Orange. Und sie sind ihre charismatischen Anführer. Viktor Juschenko, ein Mann gezeichnet von seinem politischen Kampf. Und Julia Timoschenko, die Frau an seiner Seite. Während er verhandelt, treibt sie die Menge voran. Und die Staatsmacht gibt dem Druck nach. Am 26. Dezember wird die Stichwahl wiederholt. Ein Sieg der Demokratie. Wir haben so darauf gehofft. Jetzt wird die Ukraine endlich frei. Ich bin einfach glücklich. Doch es gibt auch Demonstrationen in Blau. Blau ist die Farbe des Ostens. In den Industriestädten der Ostukraine ist man Russland nahe. Die orangene Revolution von Kiew ist weit weg und wird hier nicht gewollt. Wir wollen Juschenko nicht, wir wollen Janukowitsch. Er ist unser Mann, er bezahlt hier unsere Löhne. Die Ukraine, Europas Riese, geht einer ungewissen Zukunft entgegen. Hoffentlich einer friedlichen. Der deutsche Wald ist so krank wie nie zuvor. Nur ein Viertel der Bäume sind noch gesund. Heiße Sommer und saurer Regen sind schuld. Eine kranke Buche krallt sich noch ans Leben, vergebens. Der Waldzustandsbericht der Ministerin niederschmetternd. Mehr Klimaschutz würde helfen. Im Dezember unterschreibt Russland das Kyoto-Protokoll, doch die USA verweigern sich weiter. Und ganz real sehen sie so aus, die perfekten Arbeitnehmer 2004. Flexibel einsetzbar und unverzagt, auch wenn es bergab geht. Sie jammern nicht über saisonale Erwerbslosigkeit und sind stets hoch motiviert. Wenn sie sich zusammenrotten, dann nicht aus Protest, sondern im Dienste der Fort- und Weiterbildung. So wie hier bei der diesjährigen Weihnachtsmann-Vollversammlung in Berlin. 150 Teilzeit-Weihnachtsmänner und eine nicht unbeträchtliche Anzahl Engel werden geschult. Auf dem Lehrplan stehen richtiges Beschenken und korrektes Weihnachtsmannverhalten. Na dann, schöne Bescherung und mögen ein paar Engel uns begleiten im neuen Jahr 2005.
Die weltweit größte und stärkste Trägerrakete ist erfolgreich ins Weltall gestartet. Delta IV Heavy hob nach mehrfacher Verschiebung von Cape Canaveral aus ab. An Bord der Riesenrakete ein mehr als 6 Tonnen schwerer Satellit, der in rund 36.000 Kilometern Höhe ausgesetzt werden soll.
Die größte und stärkste Trägerrakete hat es erstmals erfolgreich ins All geschafft. Mit 50 Millionen PS startete die Superrakete vom Weltraumbahnhof Cape Canaveral. 22 Tonnen schwere Lasten kann Delta IV Heavy transportieren. Der Hersteller Boeing will mit der Rakete der europäischen Ariane Konkurrenz machen.
Holiday time. A national Christmas tree on the ellipse, a tree inside the White House, of course, and a gingerbread house with musicians on the roof. Maybe they're gingerbread too. The building dresses up really beautifully for the holidays. And if there's a tree on the ellipse and a tree in the White House, you know Congress has to have a tree. Look how big it is getting hauled in for Virginia. Look how tall it stands when it's up. But it isn't just Christmas, of course.
Dreidel, 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 I made it out of sleigh.
This is the National Menorah. Music here too, and a dreidel, that's a top used in a game played at Hanukkah, and people dancing, and the lights get lit. And other folks are celebrating Kwanzaa, a holiday honoring African Americans' heritage. That's private, but a national menorah, a national Christmas tree? What about this constitutional separation of church and state? Americans united for that separation are somewhat critical.
I'd certainly get rid of, from government spaces, all of these obviously religious symbols like nativity scenes, menorahs, and other religious symbols and icons of the season.
But Christmas trees? Sure, the carols are religious, and Santa was St. Nicholas before he was Santa, but hey, it's the season.
I think in most communities there is enough of a secular meaning for Christmas trees, although they are called Christmas trees, that people can put that up even if they're sponsored by government.
Why ever not? We Americans are a diverse people. We come from all over, different heritages, different traditions. Some will worship this holiday season in a variety of faiths. Some will shop until they drop, celebrating things, not faith. Some will eat too much or spend a quiet day with family and friends. Some will be welcoming family members back from or watching them go off to a war. Americans of all kinds, seeking all kinds of happiness these wartime holidays. Bruce Morton, CNN, Washington.
Good afternoon, good evening, and Merry Christmas from the International Space Station Flight Control Room at the Johnson Space Center in Houston, where at this hour a team of U.S. flight controllers is on console, working in tandem with a comparable team of Russian flight controllers a half a world away in the final stages of the arrival of a cargo ship called the Progress 16 to the International Space Station just over an hour from now. On this Christmas Day, with the arrival of this Progress 16 cargo ship, the unpiloted Progress 16, just an hour away, the crew on board the International Space Station, Station Commander, Expedition 10 Commander, and Science Officer Leroy Chow, seen on the left, and Russian flight engineer Salizhan Sharipov, seen on the right, are awake. They will be monitoring the arrival of the Progress 16. Sharipov will be in the Zvezda service module, ready to take over manual control of the flying of the Progress on the highly unlikely occasion that the automatic Kurs rendezvous system would encounter a problem of some sort that would require Sharipov to manually fly the Progress in for a docking to the aft port of the Zvezda service module. But Chow and Sharipov are eagerly awaiting the arrival of the Progress. They were awakened at about 4 a.m. Central Time this morning. Basically, this was an off-duty day for the crew until a couple of hours ago when the crew began to set up cameras for the documentation of the arrival of the Progress, which contains 2.5 tons of food, fuel, oxygen, supplies, and Christmas presents for the crew. A short time ago, we received confirmation from Russian flight controllers that the solar arrays on the Zarya control module as well as the Zvezda service module have been feathered or positioned in the edge-on position to prevent any inadvertent pluming of those arrays from the jet thruster firings on the Progress during the final stage of its fly-around and docking to the International Space Station. A few minutes before that, the Electrical Systems Officer here in the International Space Station Flight Control Room also confirmed that the U.S. solar arrays have been feathered and positioned edge-on, also to prevent any inadvertent damage from jet thruster firings during the final phase of the rendezvous for the Progress's docking. Here in the ISS Flight Control Room on this Christmas Day, the flight director on console presiding over operations for this portion of the crew day and this arrival of the Progress is Flight Director Annette Hasbrook, seen on the right of your screen. She is also the lead flight director for the Expedition 10 mission on the International Space Station. She is joined on console to her right on the left of your screen by European Space Agency astronaut Hans Schlegel, who will be talking to the crew if required during the course of this afternoon's activities. Again, this is a Russian operation that we are monitoring this afternoon. The Russian Flight Control Team at the Russian Mission Control Center in Korolyov outside Moscow is on duty, as they have been throughout the day. It is currently 1:33 in the morning Moscow time on Sunday morning. And the Russian Flight Control Team, the Progress experts, and all of the rendezvous systems experts are on station, along with Chief Flight Director Vladimir Soloviev, who will be presiding over the final phase of the rendezvous and docking of the Progress to the International Space Station. This is a very important Progress vehicle. They all are, of course, but this one carries additional importance because of the low food supplies on board the International Space Station. Of the 5,047 pounds of cargo being carried on board the Progress today, some 2.5 tons of cargo, 1,234 pounds of that is propellant, 110 pounds of that is oxygen and air to supply the Progress and to repressurize the cabin atmosphere if it is required at all during the time that this particular Progress is mated to the International Space Station. Also, there are 926 pounds of water and 2,777 pounds of dry cargo, as it is known. That involves a number of different types of equipment, spare parts, repair hardware, a life support system cargo, experiment hardware, and 69 containers of food. That breaks down to 29 Russian food containers and 40 U.S. food containers, which will provide some 112 days worth of food supplies for the crew on board the International Space Station, roughly twice as much as would be required until the next arrival of a Progress in early March. The 17 Progress is scheduled to be launched on February 28th and scheduled to arrive at the station on March the 2nd. Bringing additional food and other supplies up to the station. So the 69 food containers, or roughly 112 days of food for the crew on board the International Space Station, well worth the waiting and very much anticipated due to a shortage of food, a severe reduction in food at the moment on board the station due to a combination of factors which involve the amount of food that was able to be loaded on board the Progress resupply ship. The previous Progress resupply ship, the 15 Progress that arrived back on the station in August because of room that had to be made for spare parts for the environmental systems and the electron oxygen generation system on board the station, as well as the rate of food consumption by the previous station crew, the Expedition 9 crew, prior to their departure back in October, before they handed over operations to Chow and Sharipov for their current 6-month mission on board the station. So the food levels have dipped to a very low level. The crew has been eating the requisite amount of food, the requisite amount of calories. They've been apportioning food in the appropriate way as recommended by the flight surgeon community. And today's arrival of the Progress vehicle, a very much anticipated arrival of the food, the 69 containers of food, or the 112 days of food supplies that Chow and Sharipov will be getting into as the new week arrives. In addition, the cargo on board the Progress vehicle includes Christmas presents from the Chow and Sharipov families, a new printer with cartridges installed, clothing for Chow and Sharipov, medical supplies, environmental supplies, some new exercise equipment, 3 new laptop computers along with power cables, and a caseload of compact discs for the crew's pleasure, a shim assembly for one of the U.S. spacesuits on board the International Space Station that will continue the troubleshooting efforts to coax that spacesuit back into operation, new light assemblies called lamp housing assemblies for various modules of the International Space Station, and experiment hardware. And one of the Russian items that is being carried on board this Progress is an item, a robotic device called the ROKVIS, which is a Russian acronym for Robotic Components Verification on ISS Experiment, which is a German-developed robotic manipulator that is going to be installed on the outside of the Zvezda service module during the first of 2 spacewalks planned by Chow and Sharipov on January 26th.
To the SSC before I can press that button to send it to the ground. That is the soft key. Right now it's grayed out. I can't select it. So at 2250 we begin configuring the steps for the video and send it out of the FGB. And I believe at that time, hopefully that soft key will become active and I can push it and send video to the ground.
Leroy, thank you, and we copy.
Aboard the International Space Station, you heard Commander Leroy Chow talking to the flight controllers here on the ground about the video configuration to document and downlink to the ground the arrival of the Progress vehicle. The Progress, a short time from now, will be within 9 kilometers of the International Space Station. The Core's automated docking system has been activated both on the Progress's active side and the passive side on the service module. Basically, this system sends radio beacons back and forth between the two systems, providing the Progress and its onboard computers information about its range from the station and its rate of closure, which currently is about 36 meters per second. That rate will close and be reduced significantly as the Progress arrives in the vicinity of the International Space Station. Today's docking time is 5:31 p.m. Central Time. That's about 34 minutes earlier than the original docking time that had been calculated by the Russian flight control team, but it was amended last week and put into an earlier docking time outside of Russian ground stations, which is a bit unusual, but for today's activity was deemed by the Russian side and agreed to by the mission management team to be the appropriate docking time so that the Progress would not have to station keep in close proximity to the International Space Station for about 40 minutes, which would have been the case for the later docking time. As it stands today, the Progress will conduct its fly-around of the International Space Station, about a 9-minute fly-around from about 5:10 to 5:19 p.m., go into a station-keeping mode at about 5:19 Central Time, and then reinitiate its approach about 5:23, perhaps slightly earlier, for its expected link-up at 5:31 Central Time. At that time, the Progress and the International Space Station should be traveling just off the east coast of Brazil. It will take about another 20 minutes for us to verify the closure of hooks and latches to form a hard mate between the two vehicles. We won't be able to receive that information, we expect, until the Progress passes over Russian ground stations at about 5:51 p.m. Central Time this evening. So docking expected at 5:31. We should get quite a bit of television through the U.S. KU band communication system through the tracking and data relay satellite system, but we will not receive full confirmation of hooks and latches being closed to form a tight seal and a hard mate between the two vehicles until about 20 minutes later, when the Progress does finally pass over Russian ground stations.
Хорошо слышим, как нас.
Moscow, how do you read me? Loud and clear. Saluzhan, how us?
18 километров.
Loud and clear. The range is 18 and the rate is 28. Copy. Thank you. We have received all the information under the ground station. Everything is nominal, no issues. At 22:49 we activate VHF 2D and then TV at 22:50. Copy. Hopefully after 22:50 we'll be receiving the picture, high quality picture.
Russian flight controllers relaying information to Saluzhan Sharipov on board the International Space Station. The range is currently just under 17 kilometers between the Progress and the International Space Station, with a closure rate of about 26 meters per second. The stage for today's arrival of the new Progress 16 cargo ship to the International Space Station began on Wednesday afternoon with the undocking of the previous Progress ship, the Progress 15, that had originally arrived at the International Space Station back in August. This video from a black and white camera on the Progress 15 craft showed the undocking at 1:37 p.m. Central Time on Wednesday as it backed away from the aft docking port of the Zvezda service module, the same port to which the Progress 16 unpiloted cargo craft will link up just 47 minutes from now. Again, it took some minutes for the Progress to automatically back away from the International Space Station to a safe distance. Thrusters were fired on the Progress to help it along to the point several orbits later when its engines were commanded to fire in a deorbiting maneuver to send the Progress into a destructive reentry into the Earth's atmosphere where it burned up over the Pacific Ocean. Again, this video that you're looking at was captured on Wednesday when the Progress 15 departed the Zvezda service module loaded with trash and discarded items from the International Space Station no longer needed. It burned up into Earth's atmosphere a short time later. That set the stage for the launching on Thursday of the current Progress cargo craft, which lifted off just after 4:19 p.m. Central Time on Thursday, which was 3:19 a.m. Baikonur time from the Baikonur Cosmodrome in Kazakhstan on Friday morning. Temperatures were just hovering over the 0 mark Fahrenheit at the launch site, but acceptable conditions were in place for the launching of the Progress vehicle, which lifted off again at 4:19 p.m. Central Time.
17,500.
The Progress lifted off again at 4:19 p.m. Central Time on Thursday afternoon from the Baikonur Cosmodrome in Kazakhstan. Less than 10 minutes later, it was safely in orbit. Just moments after that, its appendages, its forward docking probe, its solar arrays, its communications antennae were successfully deployed. And the Progress since then has executed several rendezvous maneuvers, burns of its engine to fine-tune its course to the International Space Station. In fact, there were several burns that were conducted on Thursday afternoon and evening. One burn was conducted yesterday. Another burn occurred about an hour or so ago, and the Progress is right on the money for an on-time docking less than 45 minutes from now to the International Space Station. There will be a series of a few impulses or minor burns of its engines, mid-course correction burns, if you will, to refine its path to the International Space Station prior to the time that it arrives in the vicinity of the station. There will be a series of additional burns to place the Progress directly behind the aft docking port of the Zvezda service module that you see in this picture. This is the current configuration of the station as you look along.
11.8, copy solution, 11,800.
As you look at that graphic again of the current configuration of the International Space Station from left to right along the longitudinal axis, that is pressurized mating adapter number 2, the docking port for space shuttles that will resume next year, the Destiny Laboratory, the huge truss structure of the International Space Station mounted on top of the lab, and then to its right, just shaded around the center portion of your picture, that's the Unity module, the node that connects the U.S. and Russian segments of the station. The Soyuz vehicle, you can see docked to the nadir port of the Zarya module, and then the Zarya module itself, and on the far right of your screen, the Zvezda service module. Without the Progress attached, the Progress, of course, will be docking to the aft port. As you can see in this image, in this graphic, you'll see the location of the Progress once it docks to the International Space Station just 43 minutes from now.
We are monitoring the automated rendezvous. Okay, we'll wait for the range of 9 kilometers prior to activation today. How copy? Copy that, and we're ready. The range is 10.5. Copy.
Again, today's arrival of the Progress being carefully monitored by both U.S. and Russian officials because of the low supply of food on board the International Space Station. And again, among the 2.5 tons of cargo being carried to the station on this Progress, 69 food containers, 40 U.S. containers, 29 Russian containers, with enough food for another 112 days worth of food supplies for the crew, on top of about 2 more weeks of food that the crew currently has. In the unlikely event that a docking could not be achieved tonight for some unexplained reason, consideration then would be given to the possible decrewing of the International Space Station. U.S. and Russian managers would be discussing that possibility over the next couple of days or so before a determination would have to be made on a final decrewing of the station, again, in the highly unlikely event that the Progress would not be able to dock to the International Space Station this afternoon.
Activating. Not eligible. Copy.
We're at the point in the Progress timeline where the crew is in the process of activating a command link from the Zvezda service module to the Progress that activates the so-called Toru system. That is the telerobotically operated rendezvous system, basically the joystick system that Salizhan Sharipov will be manning in the highly unlikely event that the Corps' automated rendezvous system would encounter a problem during the final phase of the rendezvous, enabling Sharipov to manually fly the Progress in for its link-up.
2. Copy. Activating order 2. Salizhan, you have a go to activate Toro. Salizhan, you have a go to turn on TV.
Sharipov sending commands to the Progress vehicle to activate its television system. Again, because the docking is scheduled outside of Russian ground stations, we will not be seeing, we don't believe, the typical black and white cross-haired view from the Progress as it approaches the aft docking port of the Zvezda service module for link-up. However, we do expect to receive television views from U.S. cameras, the Canadarm2 robotic arm cameras, as well as the lab television camera, as well as any other cameras on board the International Space Station from the crew. We expect to have a solid KU-band communications link from the International Space Station during the entire final phase of the rendezvous, and we should be receiving television in about 15 minutes or so once we acquire a signal through the tracking and data relay satellite system.
Has been issued, VKO 2 and FGB-X, where we can see the station and center of VKO. Copy. The range is 7.
At a range of 7 kilometers, Salizhan Sharipov telling Russian flight controllers that he can see a television picture on board the station and a television monitor in the Zvezda service module through the command link, the television link from the Progress to the station's Russian segment. Again, we are not privy to that view because we are out of range of Russian ground sites at the moment. However, Sharipov is getting a view of that camera view from the Progress, the black and white television camera with the engineering overlay of data that will enable him, if required, to manually fly the Progress in for a docking in the unlikely event the automated rendezvous system experiences a problem.
The backup power. And we have the transition, BPS in the initial. The command has been issued, done, and I'm ready to test RUO.
Отклоняй РУО влево. Есть прохождение команд.
Decline to the left, the command has been executed. To the right, the command comes through, upward.
Есть прохождение команды.
The command
РУО вниз.
goes through, downward. I have the lamps illuminated on a roll. To the right, on a roll. Got it. The command has been through. Root test left. The command is through. To the right. The command comes through. Upward. The command done. Downward. Done. Copy.
На торможение.
For braking. Done. Got it.
На разгон. Есть прохождение.
Acceleration. Got it.
Тест РУО.
The road test has been done. Is over.
Sharipov confirming a good test of the telerobotically operated system on board the International Space Station's Zvezda module. Again, that is the manual system that Sharipov will have his hands on in the unlikely event of an automated rendezvous problem with the CORS system, the automated system that is currently functioning perfectly, providing data between the Progress and the service module on the range of the Progress from the station, which is about 5 kilometers at the moment, and the rate of closure, which is about 11 meters per second.
Getting the image down in the Mission Control Center. The send video to ground button is still grayed out, although I'm getting an image on the SSC. Stand by.
ISS to Moscow on SG-1. Go ahead. Salijan, have you issued a command for TV2 relay on the FGB? Yes, it's been done. Relay to onto FGB. Copy.
У вас есть картинка, нет?
You're receiving a picture? No, not yet.
ВКУ-2 увидите изображение?
Can you see the image through VKU2? That's FM.
И на ВКУ-2 у нас есть...
We have the image on VKU2.
Повреждение в SSC тоже есть, но сейчас есть маленькие проблемы с software.
There's a minor problem with the software. I'm going to warn Houston about that. Copy, Leroy.
Дальность 4200, скорость 11.
4200, this is the range, and the rate is 11. And BVS is all nominal, physical 4.
The International Space Station and the Progress currently flying over the South Pacific. About to begin a swing that will carry it a short time from now across the southernmost tip of South America and then up the east coast of that continent. Docking is expected just 33.5 minutes from now, at a point at which the Progress and the station would be just east of Brazil. Again, as you see, the docking time scheduled at 5:31 p.m. Central Time outside of Russian ground stations at the request of the Russian flight control team to prevent the Progress from station keeping for an undue period of time. The original docking time of just after 6 p.m. Central Time was revised earlier in the week at the request of the Russians so that the Progress would not have to spend an inordinate amount of time in a station keeping procedure.
The range is 3.3. The rate is 11 meters. Copy, sir.
And this camera, the lab television camera on the International Space Station, that dot that you see at the top of the screen is the Progress 16 vehicle, currently at a range of about 3 kilometers away from the International Space Station. This whole sequence is automatically programmed on the Progress for a docking. It is currently closing at a rate of about 11.5 meters per second, and again, that is the Progress, as you can see in this video that is being captured by television cameras on the International Space Station and downlink through the tracking and data relay satellite system.
Send the video to the ground. I'm wondering if I'm somehow open an old version of the software, and what I've done is on the desktop I've opened station apps, COS, and the video software there, and I thought that's what I did yesterday, but I don't see a button that says send video to the ground. And if you can suggest another location to look for a better copy of this software, I'm ready.
The range is 2.7. SKD is on.
And Leroy, we are checking down here. Stand by.
Salijan, we don't have a picture yet.
Есть выключение СКД.
SKD is off. Range is 2300. Range rate is 4.5. Salijan, which monitor are you watching the picture on? The video monitoring unit, the VKU, and symbol. Copy. Do you have a picture on the SSC?
With some more words.
There is a software problem on the SSC.
And Hans, basically the procedure, the path and the procedure does not work. That is, I cannot go to the start menu, station apps, COS apps, because there is no selection in that menu on that SSC to go open this video program. So I had to go open the station apps directly on the desktop, go into the COS folder, and then find the video converter program. And so what I think maybe yesterday I found a different version. I must have maybe on the file server. Is there a copy on the file server, on one of the drives on the file server? I can go find a copy of this program.
Leroy, we are checking.
Range rate is 4.5. Copy.
Условие с единичкой 7.
1 and 7. Copy.
Мишень в центре.
The target is in the middle. The station is in the middle of VKU. Range is 1800. Range rate is 4.5. Copy.
Дальность 1700.
Range is 1700. Everything is nominal. Copy.
Coming up on the 1 kilometer mark for the Progress that you see in this downlink television captured by television cameras on the International Space Station. That is the Christmas sleigh for Leroy Chow and Salijan Sharipov, carrying 2.5 tons of food, fuel, oxygen, air, water, and cargo, including 112 days worth of food supplies.
The station is 1 degree 1 tack higher than the center of the VKU.
Again, everything going very smoothly, flawlessly so far in the final approach of the Progress for the docking to the aft port of the Zvezda service module just 28 minutes from now at 5:31 p.m. Central Time. The visiting vehicles officer here in Mission Control, Tony Foti, reporting that all progress systems continue to look good, according to the Russian ballistics experts that he is in touch with at the Russian Mission Control Center in Korolyov outside Moscow.
Station. Copy. We can see the station structure. The range is 1270 and the range rate is 3.8. Copy. The station is in the center of the VKU. Range is 1200. Range rate is 3.6. Copy. Salijan? Please issue the command to relay TV2 through FGB -X. Copy.
You can see jet thruster firings on the Progress as it approaches the 1 kilometer mark from the station. Its range is currently just over 1 kilometer. The rate of closure now has been reduced to about 3 meters per second, all automatically programmed on board the Progress. Salijan Sharipov is also relaying information that he is seeing on a video monitor in the Zvezda service module from a television link that he is receiving from the Progress, which is still out of range of Russian ground stations. The docking will occur outside of the range of Russian ground stations, with the only video available from U.S. resources, both the Canadarm2 cameras and the lab television camera that you're seeing right now. A good view of the thruster firings on the Progress vehicle as it fine-tunes its path for a docking just 26 minutes from now.
Confirmed. Copy. The station is drifting towards the bottom left. Copy.
Yeah, Leroy, we come up with a recommendation to repeat step 4.1 again.
Range is 920.
Okay, and Hans, I've opened up the properties on the screen, and I've noticed that the monitor under the displays tab, it says not connected, and I checked the connections, they're all connected, so I'm not sure what to...
Copy. Rotation back, 850, 2.8. Copy. How copy? Read you loud and clear. Copy. Rotating back now.
Just a few minutes from now, the Progress will begin about a 9-minute fly around to position itself at a point about 100 meters or so directly behind the aft docking port of the Zvezda service module for about 4 minutes worth of station keeping.
Everything is nominal. The station is in the center of the VKU. No issues. 720. Range rate is 2.7. Copy.
This docking occurring very late in the crew day, which began at about 4 Central Time this morning with its wake-up call.
2.6. Copy.
Once the docking is accomplished, about 2.5 hours later, the crew will begin a 9-hour sleep period just after 8 p.m. Central Time, awakening Sunday morning. The hatch to the Progress will actually not be opened until just after noon Central Time tomorrow afternoon.
560. Range rate is 1.9. Attitude control thrusters are firing a retrograde burn. Range rate is 1.5. Range is 540. 540. Copy. Attitude control thrusters off. Range rate is 1.3. Range is 520. Copy.
метров,
500 meters, 1.4. Copy. We still don't have pictures, so we expect a detailed report from you, a running commentary. Copy. The station is in the center of the VKU. Retrograde confirmed, 450 meters. Range rate is 1 meter. 440 meters. It's firing a retrograde burn. Attitude control thrusters off. Range rate is 0.7. Range is 430. Copy. The station is 2 degrees left of VKU center. Copy. We're looking at the antenna. Copy. 420. Range rate is 0.8. Copy.
You can see the Progress vehicle now just 20 minutes or so away from docking, just above one of the huge U.S. solar arrays on the P6 solar array truss structure as it continues its final approach automatically towards the International Space Station, now just under 400 meters away from the station, closing at a rate of under 1 meter per second.
Copy.
If you have an idea of what to try, I'm certainly open to suggestion.
Fly around is underway. Adjusting pitch. Copy. Range is 360. Range rate is 1 meter. Copy.
градусов до окончания.
60 degrees.
Russian flight controllers confirming that the Progress has begun its 9-minute fly around of the International Space Station to position itself directly behind the Zvezda service module, where it will begin about 4 minutes worth of station keeping at about 5:19, about
pitch-wise, right, exactly. We're
7.5 minutes from now.
Salejan, how far, how much further do we have to go? It's 60 degrees. Copy. The station is drifting towards the right. We are switching to the other antenna. Copy. Thruster firing confirmed, 300 meters. Copy.
The Progress and the International Space Station orbiting at an altitude of 225 statute miles, approaching the southwest coast of Chile. About to begin a southwest to northeast swing along the east coast of South America. The docking that is scheduled about 18.5 minutes from now should take place at a point at which the two vehicles are just east of Brazil, not far from Rio de Janeiro.
1 degree to the right and 2 degrees below the center of the VKU.
Docking still scheduled for 5:31 p.m. Central Time. Everything on track for an on-time link-up of the Progress to the International Space Station.
Fly around, that is correct. Copy. 30 degrees to completion of fly around. 30 degrees. Copy.
30 more degrees until the Progress is aligned properly to the aft end of the Zvezda service module. This view coming from the television camera at the end of the S1 truss, the starboard 1 truss of the International Space Station. The Progress continuing to fire its thrusters in its automated sequence of mid-course correction firings to fine-tune its approach to the station, now just 220 meters or so away from a link-up.
There is a little interference. Phasing in and out. Range is 200 meters. Range rate is 0.7. Copy. Fly around continues. 1 and 7. Thruster firing confirmed. Retrograde. The station is drifting towards the right.
These are visual reports being given by Salijan Sharipov from the television picture he is receiving on board on a television monitor in the Zvezda service module during the time now that the Progress and the station are out of range of Russian ground stations, providing visual cues for the Russian flight controllers at the Russian Mission Control Center outside Moscow as to what he is seeing from the Progress's television camera.
We are adjusting roll. So we're complete with the pitch fly around. That is correct. Copy.
$160
meters. Station keeping confirmed. We are in berthing mode. Berthing acquired. We're waiting for berthing mode to confirm.
A couple of minutes ahead of schedule, Sharipov confirms that station keeping has begun. The Progress 16 cargo ship, 166 meters directly behind the aft docking port of the Zvezda service module.
Copy. Everything is nominal. We're station keeping. Copy. Salijan, we still don't have the picture. Copy. Things are fine. Copy. We're waiting for to mode to final approach. Copy.
Docking is scheduled about 14.5 minutes from now, at a point at which Progress and the International Space Station will be flying off the east coast of Brazil, just south of the equator. We will be standing by after that. After contact and capture are confirmed, we'll be standing by for official confirmation of the hookup of the hooks and latches to form a tight seal and a hard mate between the two vehicles. That may not occur until we come into range of Russian ground stations at 5:51 p.m. Central Time. We'll be standing by for any possible earlier confirmation of a tight seal and a hard mate between the two craft. Again, the Russians elected earlier in the week with concurrence by the mission management team to conduct this docking of the Progress automatically outside of Russian ground stations in darkness off the east coast of Brazil to minimize the amount of time the Progress would have to station keep directly behind the International Space Station's Zvezda module.
Salijan, Go ahead. Since we don't have video, we're waiting for Russian ground site AOS. So we're going to station keep during the night pass. We will start final approach at about 54 minutes. Copy. Salejan, monitor that we're station keeping. The searchlight is supposed to be on. And keep us posted. We are going into the night pass in about 10 minutes. Is that correct? Yes.
Docking is scheduled about 2 minutes after orbital sunset. You can see this large solar array at the top of your screen. That is one of the solar arrays on the Zvezda service module that is masking the view of the module itself. And you're also seeing there the radiator deployed from the S1 or Starboard 1 truss of the International Space Station. Once again, this Progress carrying 5,047 pounds of cargo, including 1,234 pounds of propellant, 110 pounds of oxygen and air, 926 pounds of water, and almost 2,800 pounds of dry cargo, including 69 food containers, 40 U.S. containers, and 29 Russian food containers, for a total of 112 days' worth of food for the crew on board the International Space Station, more than enough before the expected arrival of the next Progress vehicle in early March. Russian flight controllers evaluating the alignment of the Progress to the aft docking port of the Zvezda module. The automatic computers will reinitiate the final approach for docking just a moment or two from now. Salejan, how are you doing? Everything is nominal. Copy. This is Mission Control Houston. The Russian flight controllers have decided, after all, to allow the Progress to station keep in its current position about 160 meters or so away from the aft docking port of the Zvezda service module, and now have reversed course and have elected to wait until we come into contact with Russian ground stations about 28.5 minutes from now, so that they can have the benefit of a television picture from the Progress to ensure a safe and smooth docking of the cargo ship to the aft docking port of the service module. So again, the Russian flight controllers have just reversed course and have elected to extend the station keeping time of the Progress at the 166 meter point behind the aft port of the Zvezda service module. We expect docking now to occur about at the top of the hour, somewhere around 6 p.m. Central Time. All of the Progress systems are functioning perfectly. There are no issues being worked by the flight control team, either here in Houston or in Moscow, but the Russian flight controllers who are in charge of this Progress docking operation have changed their minds and have elected to go with telemetry and with a television picture from the Progress cameras once we come into ground station acquisition over Russian ground stations about 27.5 minutes from now. Again, docking now scheduled in the neighborhood of 6 p.m. Central Time.
Since I can't get it to recognize the load, last thing I can think of is trying to switch the AVAU before giving up. We've got a couple of minutes. If you'll cycle power off for me, I'll go ahead and try that.
I can see the solar arrays and the U.S. segment.
Большой диаметр можете оценить по маске?
Can you assess the size of the large diameter from the mask? No. Not right now. I can assess the size of the P1 truss. We are at 150 meters, and there are about 2 degrees drift back and forth. The range is 150, no change. Take a look at the solar arrays and monitor range to make sure it does not change. Yeah, everything is fine. We are gauging and station keeping. Copy. Apparently, the video link is not working, although it was yesterday.
To recap, the Progress cargo ship carrying 2.5 tons of food, fuel, oxygen, supplies, and Christmas presents for Leroy Chiao and Salijan Sharipov on board the International Space Station, passively sitting in a station-keeping mode about 160 or so meters behind the aft docking port of the Zvezda service module that you see on the far right of this graphic. That's where the Progress will be docking to at around 6 p.m. Central Time, about 30 minutes from now. We should come into acquisition over Russian ground stations about 20 minutes from now as the Progress and the station fly within range of the Russian ground station network. The Russians originally had planned to conduct this docking over Russian ground stations, then earlier in the week decided to go for an earlier docking off the east coast of Brazil outside of Russian ground stations to avoid any lengthy period of station keeping for the Progress outside of the Russian ground station network. However, at the time that the station keeping was initiated, the Russian flight controllers reversed course and informed us that we were going to go back to the original plan and wait until the station and the Progress flew over Russian ground stations to enable the Russians to have the benefit of television from the Progress black and white television camera along with data, and to be able to employ all of that real-time data in the final approach of the Progress for its link up to the aft port of the Zvezda service module. All of the Progress systems are functioning perfectly as they have been since it was launched 2 days ago from the Baikonur Cosmodrome in Kazakhstan. Progress and the International Space Station flying just off the east coast of Brazil, approaching the equator, flying at an altitude of 225 statute miles from southwest to northeast. This docking now will occur over Central Asia within range of Russian ground stations to provide real-time television and telemetry from the Progress television camera and other Progress systems for the flight control team of the Russian Mission Control Center in Korolyov outside Moscow. And you can see this close-up view of the tracking map in the front of the International Space Station Flight Control Room with the graphic portrayal of Santa and his reindeer as they fly in tandem with the International Space Station on this Christmas night. The sleigh of the Progress 16 with Santa carrying 2.5 tons of cargo and all of that food for the crew on board the International Space Station, now expecting to arrive at its docking port about 26.5 minutes or so from now. But again, with Christmas having come and with the Christmas spirit prevalent here in the International Space Station Flight Control Room, this graphic portrayal showing Santa and his reindeer approaching the International Space Station in the form of that Progress 16 cargo ship. This is Mission Control Houston. Everything proceeding well for the anticipated docking of the Progress resupply ship to the International Space Station some 25 or so minutes from now. We are expecting that link up now to occur around 6 p.m. Central Time. This was the original plan that the Russians had invoked for the docking over Russian ground stations, which is the traditional approach to the arrival of a Russian vehicle to the International Space Station. Earlier in the week, the Russians had reversed course and had elected to go for an earlier docking time of 5:31 p.m. Central Time to avoid a lengthy period of station keeping in darkness by the Progress at a distance of about 166 meters behind the Zvezda service module. But as the time for station keeping approached and began, the Russians elected to go back to the original plan. It is their operation this evening. The U.S. flight control team is standing by, working in tandem with the Russian flight control team at their control center in Korolyov outside of Moscow. The Russians electing to go back to the original plan and wait until we pass over Russian ground stations about 14.5 minutes from now to acquire television from the Progress's black and white television camera, along with real-time data that will facilitate the link-up that will occur in darkness over Central Asia. All of the Progress systems are functioning perfectly, all of the station systems are in good shape, and the crew is standing by awaiting the arrival of the Progress vehicle.
To upper control room on SG-1, go ahead. How copy, Salijan? How do you read? Read you loud and clear. Everything is fine. We are station keeping at 150 meters. Everything is clearly visible. The station is drifting to the left for some reason. Copy. To the other antenna. How much left? Completely to the left. I can see the right wing of the solar array right now. Copy. Range is 158. I'm flight director unintelligible. Salijan, watch it. It's probably going to settle down. We're just going to go to the other antenna. I cannot gauge the range right now. Yeah, I can see the U.S. segment barely visible. It's about 1.5 degrees in range.
U.S. cameras on the International Space Station showing the illuminated Progress 16 cargo ship sitting about 150 or 60 meters behind the aft docking port of the Zvezda service module in a station-keeping mode, as we are about 10.5 minutes away from passing over Russian ground stations, at which point the station keeping will be completed and automatic computers on the Progress will reinitiate its final approach for a link-up that is now expected around the top of the hour at about 6 p.m. Central Time. All of the Progress systems are functioning normally. The docking about 30 minutes behind the schedule that the Russians had elected to go for earlier in the week. They changed their minds after the Progress began its station-keeping mode at about 5:15 Central Time, about 26 minutes ago, electing instead to wait until the two craft passed over Russian ground stations to take advantage of the black and white television camera views from the Progress, as well as real-time telemetry and data being received from the cargo ship itself. The Progress's systems continue to function normally, everything in good shape on the Progress as we stand by for the resumption of the approach of the Progress to the International Space Station's aft docking port of the Zvezda module.
Is it stable? Yeah, we're stable at 160 meters. Rocking back and forth, give or take a couple of degrees. So you're on the other antenna right now. That is correct. It is drifting towards, it's drifting upwards, about 4 degrees higher. 4 degrees up from the center of the VKU. And it's going back and forth, rocking back and forth. Salijan, keep reporting. Just report. Everything is nominal. I'm watching it. I'm watching the range and I can see the station. Copy. Good job. And Leroy is also watching it, so things are fine. Copy. And I'm not seeing the engine compartment, and this is something that I don't like. But judging from the angular size, I can gauge the range. We're 1.5 degrees stable. Copy, and keep evaluating for us. Can we activate wide angle right now? No, not right now. Okay. We're getting the picture. Already? From the station. Are you getting the video? Very weak. Okay, I understand. One is phasing in and out of the S word. There is some rocking going on. There is a lot of difference. Is there a lot of difference between course and range forecast? It's 0.02, 2 meters. That's fine. Salijan, can you see the station well? Yes. We are planning to issue the command to enable final approach at 0249 DMT via S-band in about 3 minutes. Copy.
As you hear, flight controllers at the Russian Mission Control Center in Korolyov outside Moscow discussing the final procedures with flight engineer Salijan Sharipov. They expect to be sending commands to the Progress about 3 minutes or so from now that would initiate the final approach for docking. We will be passing over Russian ground stations about 4 minutes from now, at which time we are hoping to be in receipt of downlink television from the black and white TV camera on the Progress cargo ship as it passes over Russian ground stations, along with real-time telemetry for the benefit of the Russian flight controllers who purposefully delayed the docking by about 30 minutes to take advantage of the Progress and the station flying over Russian ground stations.
Attitude control thrusters, and briefly you're going to go to indicator mode. Copy.
And this view now from the Progress's black and white television camera relayed through the U.S. systems on board the International Space Station just prior to the time that we will go AOS over, or acquisition of signal over Russian ground stations, 3.5 minutes from now, showing the view from the Progress as it sits passively about 160 meters directly behind the aft docking port of the Zvezda service module. You can see the crosshairs and the engineering data on this black and white television camera that will be relayed, that is now being relayed to the Russian flight controllers to enable them to initiate the final approach for docking while we are in transition going over Russian ground stations about 3 minutes from now.
Seeing it too. The signal is coming through. Where did it come from, I wonder? So we should be enabling final approach shortly. I can't see it yet. Now it's working. I don't know why.
We are standing by for the initiation of final approach by the Progress for docking to the International Space Station with its cache of goods and its 2.5 tons of supplies and food for the residents on board the complex.
Okay. Where's the final approach? No final approach yet. Yeah, it's adjusting attitude. We're in final approach mode. We can see that.
The visiting vehicle officer here in Mission Control confirms to Flight Director Annette Hasbrook that the Progress has initiated its final approach for docking. The docking port at the aft end of the Zvezda service module will come into a direct range of the center of those crosshairs, providing the Progress with its automated rendezvous system all of the data it needs to be able to make its final approach with perfect alignment to that docking port.
Oh,
there is some interference.
You're looking right at the aft docking port of the Zvezda service module, the final destination for the Progress and its Christmas cargo.
We're monitoring it. Everything is nominal.
We will be passing within range of Russian ground stations just a few seconds from now.
At 30 meters, activate, execute. Range is 87.
87 meters separating the Progress from its final destination, the aft docking port of the Zvezda service module of the International Space Station. In the lower left-hand quadrant of this view from the Progress camera, you can see the Soyuz TMA-5 vehicle, the capsule that brought Leroy Chiao and Salijan Sharipov to the International Space Station 71 days ago.
See the target. Range rate is 0.35, range is 65. Excellent.
Again, the docking was purposefully delayed by the Russian flight control team, extending the station keeping time for the Progress behind the aft docking port of Zvezda, an additional 30 minutes or so, to enable this link up to occur over Russian ground stations with the benefit of the television views you're now seeing along with real-time telemetry. "53 meters now separating the two craft. The Progress closing at a range at a rate of about 0.2 of a meter per second.
Copy, going to VHF. How copy? Read you loud and clear. How us? Read you loud and clear as well.
Есть маленький там маленькое движение по угловые там.
There is small motion in pitch and yaw. We're 1 degree below. Range is 40. Range rate is 0.2. We're getting the picture, so you can also comment in detail. The crosses are aligned. Drifting 1 degree to the right. Copy.
This video is being routed through the U.S. Ku-band communication system through the tracking and data relay satellite system. We'll be losing this link in about a minute. We're in the process of locking up the television picture over Russian ground stations.
Range is 43. Range rate is 0.23. Copy.
Everything proceeding normally in this final approach of the Progress for link up just a few minutes from now. Range is about 40 meters, now 39 meters, closing at a rate of 0.2 of a meter per second. Again, this view now over from the television camera on the Progress resupply vehicle, the unpiloted Progress cargo craft through Russian ground stations.
Activating
32 meters separating the two craft, everything going normally.
Yes, nominal.
The crosshair target at the very bottom of the aft end of the Zvezda service module, you can see it just to the right of the crosshairs. Those the crosshairs will be perfectly overlaid over that docking target to form the perfect alignment for the Progress in the final few feet before contact and capture.
Television SSVP readiness confirmed. Copy. Range is 20 meters.
20 meters now separating the Christmas cargo for the Expedition 10 crew on board the International Space Station.
The target is in the middle. Copy. Four. Range is 15 meters. Copy.
diameter.
12 meters now separating the two craft, everything proceeding normally.
The range is 8 meters.
Now 8 meters. Good range rate reported by the Russian flight controllers at the Russian Mission Control Center outside Moscow.
Range rate is 0.18. We can see the target going up by about half a degree. Copy. 5 meters.
5 meters away, standing by for contact and capture.
3 meters.
3 meters. Copy.
1 метр, ждем касания.
1 meter, waiting for contact. Copy. Contact confirmed.
Docking confirmed.
Capture.
At 5:58 p.m. Central Time.
Hip, hip, hooray. Congratulations.
The Progress 16 cargo ship completes a flawless 2-day Christmas pilgrimage to the International Space Station. Docking occurred 225 statute miles above Central Asia, a flawless approach and docking by the Progress resupply ship carrying 2.5 tons of food, fuel, oxygen, supplies, and Christmas presents to Leroy Chow and Salijan Sharipov.
Deactivation, page 23. Salijan, can you comment on what you're doing? Sure. Work is on. ODR is being activated. Is everything nominal? Yes. Deactivating manual. Copy. Deactivating TV. Initial. Copy. Command handover. Copy. Deactivating work. Copy.
Visiting vehicle officer here in Mission Control reporting that the docking probe is now driving to begin the initiation of the hookup of the hooks and latches to form a hard mate and a tight seal between the two vehicles. Again, docking occurred at 5:58 p.m. Central Time as the Progress and the International Space Station flew 225 statute miles over Central Asia. 2.5 tons of supplies, including 112 days of additional food supplies, now linked up to the International Space Station. Hatch opening scheduled just after noon Central Time tomorrow.
Salijan, please keep commenting. Yes, issue the command TV off. Copy.
We will be standing by for confirmation of the firm hookup of the hooks and latches with the two vehicles. That should take just a few more minutes.
Yes, I'm preparing the command. Copy.
As the crew on board the station works through post-docking procedures, again, a reminder, this Progress ship that launched back on Thursday afternoon from the Baikonur Cosmodrome in Kazakhstan had a flawless 2-day transit en route to the International Space Station. The docking was delayed about 25 or so minutes purposefully by the Russian flight controllers to enable the docking to occur over Russian ground stations for the benefit of television and real-time telemetry. All of the Progress systems function perfectly from launch to docking.
Just a sec. The command has not been issued yet. Copy. Standing by.
Это 2. Выдали команду выключения резервного приемника 1 КВ-2.
Принято. Receiver 1 of VHF-2 has been deactivated. Copy. And now the VHF-2 as it is. Copy.
To recap, aboard the Progress, 5,047 pounds of cargo, including 1,234 pounds of propellant, some 110 pounds of oxygen and air, 926 pounds of water, almost 2,800 pounds of dry cargo, including spare parts, repair equipment, life support system gear, experiment hardware, and 69 food containers, 40 of which are U.S. food containers, resupplying the crew on board the station, Leroy Chow and Salijan Sharipov, with an additional 112 days worth of food, more than enough prior to the arrival of the next Progress in early March.
RU deactivation. Copy. Deactivating. PBKS and CVKU2. Copy. Is everything nominal? That's FM. Okay, thank you. Secure the handles. Control handles. Copy. Okay, thank you very much for the support. Happy New Year. Yes, best regards from the specialists and especially Volodya, that is your flight surgeon. Best regards to all of them. Andrei and Leroy also sent his hello. Say hello to Leroy from us. Okay, we're done with it. We're done with it. Okay, Salijan, thank you very much. Talk to you later. Talk to you later.
Что-то у нас команда не прошла с Москвы. Резерв, выключение резерв приемника 1 КВ-2.
Backup VHF-2 receiver has not been deactivated. The command has not been executed. Copy, Salijan will look into it. We'll check.
Ну что, я выдаю отключение.
Well, I'm going to issue the command for execution, for deactivation. Standby 1. Copy.
This is Mission Control Houston, standing by for final confirmation of the latch-up of the hooks and latches to form a hard mate between the two vehicles following the successful docking of the Progress 16 unpiloted cargo ship that occurred about 8 minutes ago at 5:58 p.m. Central Time as the two craft flew high over Central Asia. And now the visiting vehicle officer here in Mission Control confirms hooks and latches are closed, a hard mate, a tight seal now between the Progress and the International Space Station. You can see now the current configuration of the station. On the far right, the Progress docked to the aft end of the Zvezda service module, replacing another cargo ship that was discarded on Wednesday that had arrived back in August. With food supplies running low for Leroy Chow and Salijan Sharipov, this Progress successfully arriving at the station on Christmas night, delivering 2.5 tons of cargo, including 112 days worth of food in the form of 69 food containers, 40 of which contain U.S. food for Leroy Chow and Sharipov if he desires. The transit from launch pad at the Baikonur Cosmodrome in Kazakhstan to tonight's docking was flawless by the Progress vehicle, which launched Thursday afternoon, executed a number of rendezvous maneuvers over the course of the last 48 hours, setting the stage for the docking that occurred at 5:58 p.m. Central Time this evening. Chow and Sharipov will be heading to bed about 2 hours from now for an extended 9-hour sleep period. They will wake up Sunday morning, conduct leak checks between the Progress and the Zvezda service module, even though a hard mate has been confirmed between the two craft, before the hatch is open to the Progress shortly after noon Central Time on Sunday afternoon. And you can see on the front tracking map here in the International Space Station Flight Control Room that Santa and his reindeer have successfully arrived at the International Space Station, bringing well-weighted food for the crew on board, along with the other supplies and experiment hardware and spare parts. Santa arriving at the International Space Station on Christmas night, delivering 2.5 tons of cargo to Leroy Chow and Salijan Sharipov. With that, we will wrap up our coverage of tonight's docking of the Progress 16 craft to the International Space Station. Again, a successful link-up of the cargo craft to the aft end of the Zvezda service module occurring at 5:58 p.m. Central Time this evening as the two craft flew 225 statute miles over Central Asia.
Christians around the world celebrating on this holy day. For them, crowds packed St. Peter's Square in Vatican City to hear Pope John Paul II give his Urbi et Orbi Christmas message. And several thousand pilgrims made the journey to Bethlehem, the town Christians believe to be the birthplace of Jesus. The crowds in the West Bank town are a bit larger this year than they have been in recent years.
Altersschwäche und Parkinson. Der 84-jährige Papst lässt es sich dennoch nicht nehmen, den Segen selbst zu spenden, auch in deutscher Sprache.
Der Menschen wieder ein Leben mit tiefer Freude.
Johannes Paul II. Ruft zum Dialog und zur Versöhnung auf, erinnert an die Leiden in den Krisenregionen der Welt. Mit Sorge verfolge er die Ereignisse im Irak, so der Papst. Es fällt ihm sichtlich schwer zu sprechen. Immer wieder muss das stark geschwächte Kirchenoberhaupt absetzen, Luft holen, kurze Pausen beim Verlesen der Weihnachtswünsche einlegen. Der einzige Weg, Frieden zu schaffen, bestehe darin, das Böse zu verabscheuen und mutig das Gute zu verfolgen. Trotz starken Regens, Zehntausende Gläubige, darunter viele Kinder und Jugendliche, lauschen seinen Worten auf dem Vorplatz des Petersdoms. Höhepunkt der Weihnachtsfeiern in Rom war am Vortag die Christmette. Dazu hatten sich mehrere tausend Menschen im Petersdom versammelt. Eine gefährdete Welt brauche mehr als jemals zuvor die Botschaft Jesu, so der Papst mit schwacher Stimme. Erwarteten manche Beobachter an diesem Tag politische Bezüge, so wurden sie enttäuscht. Im Gegensatz zu den Vorjahren beschränkte sich das katholische Kirchenoberhaupt auf eine kurz gehaltene, rein religiöse Predigt. An der Messe nahmen neben zahlreichen Kardinälen auch Vertreter von 150 ausländischen Regierungen teil.
The 84-year-old Pope in frail health, his speech slowed by the effects of Parkinson's disease, prayed that people of goodwill of all nations heed his call for peace and dialogue. He said he was particularly concerned about current levels of violence in Iraq, the Middle East and Africa, a source of untold suffering. He referred specifically to what he called the tragedy of Darfur in southern Sudan, to the civil war in Ivory Coast and the fighting in the Great Lakes region of Africa. The Pope said he was also following the situation in Iraq with great apprehension. His somber warning on one of the great feast days of the Roman Catholic Church was transmitted live by satellite to more than 70 countries, including for the first time 4 Muslim nations, making a determined effort to carry out all his Christmas engagements despite his fragile state of health and his speech difficulties. The Pope then read out his Christmas greetings in 62 different languages. The crowd shouted their greetings back in encouragement. The Pope regards his mission to lead the Roman Catholic Church as a lifelong commitment and has made it quite clear he has no intention of resigning. David Willey, BBC News, Rome.
Die Raumsonde Huygens hat sich am frühen Morgen von ihrem Mutterschiff Cassini getrennt und den letzten Teil ihrer Reise zum Saturnmond Titan begonnen. Ein bisher einmaliges Projekt, an dem auch Deutschland beteiligt ist, und zwar mit rund 115 Millionen Euro.
Alles prima, alles bestens. Nicht nur Huygens Projektmanager Le Breton wird diesen ersten Weihnachtsfeiertag so schnell nicht vergessen. Punkt 3 Uhr mitteleuropäischer Zeit im ESA-Kontrollzentrum. Eine der spektakulärsten Missionen in der Geschichte der Raumfahrt geht in ihre heiße Phase. Nach mehr als 7-jähriger Reise durch das All hat sich die Huygens-Sonde von ihrem Mutterschiff Cassini getrennt. Jetzt ist sie auf dem Weg zum Saturnmond Titan, rund 1,2 Milliarden Kilometer von der Erde entfernt. Die Chancen stehen gut, dass Huygens funktioniert, sagt Projektmanager Le Breton. Und wir gehen davon aus, dass auch am 14. Januar nichts daneben geht. An diesem Tag soll die 300 Kilogramm schwere Sonde durch die oberen Schichten der Titanatmosphäre rasen. Ihr Hitzeschild muss dann Temperaturen von bis zu 1500 Grad aushalten. Ist die Geschwindigkeit langsam genug, wird die Schutzhülle abgesprengt. Eine Zeitschaltuhr erweckt die wissenschaftlichen Gerätschaften zum Leben. Während des gut 2,5-stündigen Sinkfluges kann Huygens dann Daten und Bilder zur Erde funken. Was es auf dem Titan zu sehen gibt, darüber wird viel spekuliert. Nur so viel wissen die Wissenschaftler: Der Mond müsste in etwa so aussehen wie die Erde vor rund 4 Milliarden Jahren. Möglich, dass Titan auch etwas über unsere Geschichte erzählt.
Die Sonde der Europäischen Weltraumagentur koppelte sich in der Nacht planmäßig vom Mutterschiff ab. Huygens soll Titan am 14. Januar erreichen. Der Saturnmond ist für die Wissenschaftler deshalb so interessant, weil er nach derzeitigem Kenntnisstand der einzige Mond in unserem Sonnensystem mit einer Atmosphäre ist.
Scientists are keen to explore Titan as it's the only moon in the solar system known to have an atmosphere.
This truly is a mission where no spacecraft has gone before. An orbiter called Cassini is studying Saturn and its magnificent rings. But now it's released a probe on a 3-week voyage to explore the planet's largest moon, Titan. Celebrations at Mission Control. Everything so far has gone to plan and the scientists are delighted.
This was one of the breakpoints. We've got over this hurdle, and now the next thing will be the descent into Titan's atmosphere.
The cone-shaped probe cost £300 million. A tough heat shield protects the delicate instruments inside. They'll be studying the chemicals in Titan's atmosphere, thought to resemble those on primitive Earth.
In a very real sense, by going to Titan, we're going back in time to our own history 4 billion years ago.
In 3 weeks' time, the craft will begin its fiery descent to the surface. Parachutes will break its fall as it plunges through the haze. It could drop down into oily seas. The probe will then send data back via its mothership before its batteries run out. Christine McGurty, BBC News.
Im Sonnensystem eine zweite Erde. Wissenschaftler glauben, dass es zumindest so etwas Ähnliches gibt, nämlich den Saturnmond Titan. Auf ihm herrschen wahrscheinlich vergleichbare Verhältnisse wie auf unserer Erde, bevor das Leben entstand. 7 Jahre lang war die europäische Sonde Huygens dorthin unterwegs. In der vergangenen Nacht hat sie sich vom Mutterschiff Cassini gelöst. Und mit Hochspannung erwarten Wissenschaftler aus aller Welt nun die ersten Bilder vom Titan. Mehr von Bernd Schröder.
Es war nur ein kleines Abkopplungsmanöver weit draußen im All, aber ein Riesenschritt für die Raumfahrt der Menschheit. Um 3 Uhr nachts lösten kleine Sprengladungen die Landesonde Huygens von ihrem Trägerschiff Cassini. Die Bestätigung über das geglückte Manöver traf wegen der Entfernung von 1,2 Milliarden Kilometern zur Erde erst über eine Stunde später in der Bodenstation der NASA ein und war dort das schönste Weihnachtsgeschenk für die Wissenschaftler. Bis jetzt sind wir sehr zuversichtlich. Wir hatten ein gutes Manöver und die Huygens-Sonde ist jetzt sicher auf ihrem Weg. Rund 2,5 Milliarden Euro kostete die Mission von NASA, ESA und der italienischen Raumfahrtagentur ESA. Schon vor 7 Jahren startete Cassini-Huygens ins All. Im vergangenen Juli erreichte die Sonde endlich ihr Zielgebiet, die Umlaufbahn des Saturns. Bereits dort lieferte sie sensationelle Bilder von den Ringen des Planeten. Doch das eigentliche Ziel der Mission ist der geheimnisvolle Saturnmond Titan, den Wissenschaftler oft als zweite Erde bezeichnen.
Der Mond Titan ist deswegen besonders, weil er eine dichte Atmosphäre hat, was für Monde absolut ungewöhnlich ist. Sie wissen, unser Mond hat gar keine Atmosphäre, der ist völlig luftleer. Und diese Atmosphäre ähnelt der Erde, bevor das Leben auf der Erde entstand.
Wenn alles nach Plan verläuft, wird die abgekoppelte Huygens-Sonde am 14. Januar in die Titan-Atmosphäre eintauchen. Während ihres 2,5-stündigen Abstiegs soll sie ihre gesammelten Daten über den Cassini-Orbiter zur Erde funken. Im Idealfall könnte Huygens sogar sicher auf dem minus 180 Grad kalten Titan landen und noch für wenige Stunden Bilder aus einer neuen Welt zur Erde schicken.
Während die meisten Deutschen bis zur letzten Minute auf Schnee gehofft haben, waren andere schlauer. Die haben sich nämlich vorsorglich aus dem Staub gemacht, und zwar in Richtung Süden. Wie sie die Festtage verbringen und wie anderswo auf der Welt Weihnachten gefeiert wird, das haben unsere Korrespondenten zusammengetragen. Sabine Tünker fasst zusammen.
Sie sehen ganz richtig, auch hier ist Weihnachten. Als wir gerade aufstanden, tummelten sich die Australier schon am berühmten Bondi Beach bei Sydney. Wie immer feierten sie gemeinsam mit vielen britischen und amerikanischen Touristen die ganze Nacht durch. Trotz eines Alkoholverbots, das die Ausschreitungen der vergangenen Jahre verhindern sollte. In Thailand findet man in diesen Tagen schon viele deutsche Touristen, die sich vor Einkaufsstress und Schmuddelwetter hierher geflüchtet haben. Am Hua Hin-Strand am Golf von Siam lassen sie sich's bei knapp 30 Grad gut gehen.
Strand liegen, schlafen, erholen vom Stress aus Deutschland.
Karten schreiben nach Deutschland.
Ach, die armen Schweine frieren in Europa.
Schöne Feiertage wünscht Israel den Pilgern, darunter auch viele Deutsche, so wie hier am Checkpoint nach Bethlehem. Wer den passiert hat, stößt auf diese Mauer rund um die Stadt. Dahinter ein nur wenig weihnachtliches Bethlehem. Zu weit weg scheint der Frieden in der Region.
Verregnete Weihnachten in Bethlehem vor der Geburtskirche, dort wo einst der Stall mit der Krippe stand. Die gedämpfte Stimmung hier an Bethlehems wichtigstem Tag macht klar, die weihnachtliche Botschaft vom Frieden auf Erden hat dieser Tage wenig Chancen, die Menschen hier mit ihren Problemen zu erreichen.
Nach dem Rekordschneesturm an Heiligabend graben sich viele Amerikaner so langsam aus. 62 Millionen Weihnachtsurlauber reisten verspätet. Auch viele Geschenke wurden eingeschneit. 11 Milliarden Dollar brachte das Weihnachtsgeschäft allein den New Yorker Geschäften.
Nach dem Kaufrausch kommt New York einmal im Jahr für ein paar Stunden zur Ruhe. Heute früh am Weihnachtsmorgen, denn anders als in Deutschland packen die Amerikaner erst jetzt ihre Geschenke aus.
Santa Claus, der amerikanische Weihnachtsmann, hatte alle Hände voll zu tun. Er beschenkte viele Eltern und heute am ersten Feiertag kann er endlich ausspannen beim eisig kalten Wassersport, bevor er heute Abend wieder auftreten muss, zusammen mit seinen Kollegen bei einer der vielen Weihnachtsshows in New York.
Ja, hübsch. Und wer wohl die einsamsten Weihnachten gefeiert hat? Das weiß Uli Potowski.
Wir hätten da einen Kandidaten. Besondere Höchstleistungen im Leben haben schon einige vollbracht. So haben 1800 Menschen schon den Mount Everest bestiegen und besiegt. Immerhin waren schon mehr als 450 im Weltall und 12 Astronauten auch auf dem Mond. Aber nur ein Mensch hat bislang eine Non-Stop-Weltumsegelung geschafft. Dieses versucht derzeit die Engländerin Ellen MacArthur. Und natürlich verbringt sie dabei ein sehr ungewöhnliches Weihnachtsfest. Marc Beetz mit den Einzelheiten.
Ganz auf sich allein gestellt, auch an den Weihnachtstagen. Ellen MacArthur ist auf Rekordjagd. Mit ihrem 24 Meter langen Trimaran B&Q will sie die Welt schneller umsegeln als je ein Mensch zuvor. Mit Astronautennahrung und maximal 3 Stunden Schlaf pro Nacht. Diese Uhr zählt die Stunden unerbittlich herunter. Für mich wäre es das schönste Weihnachtsgeschenk überhaupt, wenn ich wieder ankommen würde, bevor diese Uhr wieder auf Null steht. Vor 28 Tagen begann MacArthurs Abenteuer. Vom englischen Falmouth aus ging es über die Startlinie an Frankreich und Portugal vorbei, Richtung Kap der Guten Hoffnung in Südafrika. Derzeit befindet sie sich auf dem Indischen Ozean mit Kurs Australien und liegt gut 12 Stunden besser als der bisherige Weltrekordler Francis Joyon im letzten Jahr. Unterstützung erhält Ellen MacArthur auf ihrer 45.000 Kilometer Tour auch aus Deutschland. Der Kieler Meteorologe Dr. Menno Schrader versorgt die Seglerin regelmäßig mit Wetterprognosen und warnt vor tückischen Stürmen. Eine überlebenswichtige Beratung.
In solchen Situationen kann also tatsächlich auch das Schiff zerbrechen oder auch sie sich schwerste Verletzungen zuziehen. In dem Moment wäre selbstverständlich sowas, so ein Rekordversuch, so ein Segelunternehmen dann sofort beendet.
Und gerade jetzt bedroht eine solch kritische Wetterlage das Projekt. Für MacArthurs Kurs ist ein kräftiger Sturm mit mächtigen Wellen vorhergesagt. Ich glaube, die Weihnachtstage werden sehr, sehr hart. Ich bekomme von der Natur wahrlich keine Geschenke. Es macht mich ziemlich nervös, was da auf mich zukommt. Noch aber läuft alles nach Plan. Bald hat Ellen MacArthur die Hälfte der Strecke geschafft. Um den Rekord zu brechen, muss sie Falmouth bis zum 9. Februar 2005 wieder erreicht haben. Nach über 72 einsamen Tagen, allein auf hoher See.
Jahre war es auf seiner Saturn-Forschungsmission im Weltall unterwegs, das unbemannte Raumschiff Cassini mit der Sonde Huygens. Die macht sich jetzt zur Landung bereit. Die Raumsonde trennte sich erfolgreich von ihrem Mutterschiff und nahm Kurs auf den Saturnmond Titan. Dort vermuten Forscher ähnliche Verhältnisse wie auf unserem Planeten, bevor sich das Leben entwickelt hat. Die Mission soll neue Erkenntnisse darüber bringen, wie die Erde entstanden ist.